let's discuss on another topic which is there in this functions, that is the composition of function. Now, composition of functions are very important topic. We require this in our integration, differentiation, when we deal with continuity of functions. Everywhere throughout hereafter, we will be seeing this composition of functions. So, without delay, let's see what is composition of function. Now, as you know, what is a function? A function f that is defined from a set x to y. How did we notate that? F is a function from x to y, right? We will notate it as f being a function from x to y, right? Now, here I define three sets, right? I define three sets, namely A, B and C. So, I am taking three sets A, B and C. Let f be a function that is defined from A to B. So, I repeat, f is a function from A to B, right? And there is another function which is defined from B to C, that is given by the function g. So, I have yet another function g being a function from B to C, right? Now, we are discussing on composition. Now, let's see what is composition. Let x be an element in the set A, right? Under the function f, when we map this element under the function f, what will I get? I will get it as f of x. Where is f of x? F of x is in set B. Now, I apply the function g on f of x, right? So, first function which I applied was x from the set A to B, that is function f. So, f of x, right? X is an element of where? Capital A, set A. So, from A to B under the function f, that is given by f of x. Now, this f of x is mapped to C, that is under the function g, f of x is mapped from B to C. What will I get? G is a function that is acting on f of x, right? G is a function. G is this function acting on f of x to give you what? G of f of x. Now, what did I get? I got here two different functions acting simultaneously one after the other, right? Now, this g of f of x, that is simply I can say it is a function from where to where? From A to C, right? This function g of f of x is a function from A to C and it is notated as g o f, read as g o f, that is g of f. Okay, g of f, g o f. Some authors, they used to write this as g of and read it as gof. Okay, so that way also you can call this function. So this is, I use it as g o f, g of f. Okay, so this function g of f of x is same as what? G o f. Now, what is g o f? G o f is a function from where to where? It is a function from A to C, right? G is a function from G o f is a function from A to C, A to C. So, it is notated as G o f. So, I can write it as what? What is the composition function? I can write the composition function as if f is a function from A to B and g is a function from B to C, then g o f is a function from A to C. Such that to complete the definition, I can write it as g o f is a function from A to C, such that what is this function g o f? G o f is equal to g of f of x. Now that is complete. G o f is equal to g of f of x for all x belonging to where? Belonging to the set A. Belonging to set A. So this is all about g o f, right? G o f is a function from A to C. How did we get g o f? It is a mapping from A to B f by the function f. The function f maps the elements of a to b, and then this function what I get here, that is f of x. F of x is an element in b. Now f of x is mapped to c under the function g, right? And this combination or the composition is called as GOF, right? GOF is a function from a to c. Am I clear? Okay. So now this is how I define this. Okay, now before I conclude this session, I want you to understand something from this particular composition of the function. That is, what about the domain and range of these functions? Okay, now if you look at the function f, which is the range? This set B is the range, right? And this set B, which is the range of f of x, is now going to be the domain of G. Am I clear? So I can say that the range of f is a subset of the domain of G, right? The range of f is the subset of the domain of G. Either the entire range of f can come as the domain of G, or else it will be the subset of this. So for this will be true for GOF to exist. Now, for GOF to exist, what must be true? The range of f, the range of the function f, that is this, must be the subset of the domain of G. G's domain will be either B, that is what is B? That is the range. So either be the as such or the subset of B. So the range of f is the subset. The range of f is the subset to the domain of G. For what? For G of f to exist. Now just think about f of G. What is f of G? GOF. See, GOF. This is GOF, isn't it? GOF, or here again GOF. Which is the function that is acting first? It is f of x. F of x is acting first, right? That is, x is an element, then f of x happens, right? So which is the function that happens first? F of x. So GOF means this function, the function which is towards the extreme right, will happen first. That is, GOF means f is acting first. So I can say the GOF to exist, the range of f is a subset of the domain of G. That means here of GOF, I repeat, GOF means what? F is a function that is acting first. What about FOG? What about FOG? FOG means G is acting first. Right? The function G is acting first and then f. Right? G is acting first and then f. Now to see what is FOG, I consider three sets. Say as such as I have taken it here. This be A, B and this be C. The first function is from A to B and this is G. G is acting first. FOG, the extreme right acts first. The extreme right function, that is G is acting first. So G is here, X is here, G is from A to B and this is a element X. X when it is mapped under G gives you G of X. Now this G of X again under the function f, what will I get? F of G of X. Right? F of G of X. That means this gives me f of G of X. This gives me what? FOG. This gives me FOG. Right? Now FOG is a function from A to C such that the first function that acts upon this is G. G is the function that acts upon the element x first, and then it happens, then you get G of X and then f happens and then we get it as FOG. Got it? Now see about as we have dealt there the range of the function f. Now here when you look at what can you say about the range of G? The range of G, which is the range of G? This one. right? This is the range of G, which is either the subset, it's completely the domain or the subset of F, or the domain of F. So the range of G, for f of G to exist, this is the condition. The range of G must be a subset of the domain of F. The range of G is the subset of the domain of F. The range of G is the domain of F. So FOG exists. FOG exists when this condition is satisfied, and GOF exists when this condition is satisfied. If you just go through this figure, you will understand in its fullest. So here what you have to understand is a composition function is what? This is a function. The composition function is a function that is defined for two different functions acting simultaneously. That is, f is a function from a to b and g is a function from b to c. Then the composition function is given by GOF. Right? It's a function from a to c such that GOF is equal to g of f of x for all x belongings to the set A. So this is GOF, and what about FOG? FOG means which is the function that is acting first. It is the extreme right one, right? So whenever you write FOG of x, G of x is what is acting. This is exactly same as f of G of x. So G of x is the function that first comes, and then we apply f on it. Now GOF of x, what does that mean? G of f of x. F of x is the first function that we take, and then we apply g on it. Okay, now let's move on to the examples of the composition function. Before we move on to the example, we need to discuss on the properties. Certain properties also we will see, and then we will move into the examples. Okay. So what we have discussed about composition function, f is a function from a to b, g is a function from b to c, then FOG is a function from a to c such that FOG is what? F of g of x for all x belonging to the set A. Now, we had already discussed about the range and the domain that comes under the note, first note. What was that? The range of f, the function f, was the subset of the domain of G for GOF to exist, and the range of G is going to be the subset of the domain of F for FOG to exist. So I had discussed all these things very clearly in the previous session. Okay. So this is the first note that comes under this session. Now the second note is, suppose you have two functions HOGOF, right? HOGOF. What does it mean? The first function that acts is GOF, and then you find H of GOF. Now this can also be written as HOGOF. HOGOF. And the third one is FOG is not equal to GOF. This is all about the conclusion of what we had discussed. Okay. So these are certain things that comes as a note. Once again, the range of the function is the subset of domain of G for G of F to exist, and the range of G is a subset of the domain of F for FOG to exist. If you want more clarification on this, you can just draw that diagram which we had already discussed, that that figure. The former session we had discussed the figure, right? That figure you can draw and see that this is true. Now HOGOF is same as HOG of F. Now FOG is not same as GOF. This is something which we had already discussed. So these are the three listings that comes under the note session. Okay. Now let's see the examples for the composition function. Fine. Let's see the first example. So here you have a function f from R to R defined by f of x is equal to x square, and g is again a function from R to R defined by g of x is equal to 2x plus 1. You are asked to find FOG and GOF. So let me first find FOG. FOG of x, that is same as f of g of x. Now what is that? What is g of x? 2x plus 1, right? Now in the place of g of x, I wrote the value of g of x, 2x plus 1. Now f of 2x plus 1, in the place of x, what will I have? 2x plus 1 for the function f. So what will I get? 2x plus 1 the square. So this is FOG. Isn't it simple? Now finding g over f of x, which is same as g of f of x. That is g of, what is f of x, children? X square. Right? F of x is x square. Now substituting x square in g of x, what will I get? 2 in the place of x square plus 1. So this is g of f. This is FOG and this is GOF. This is how I do the problem. Now coming to the second part of the question, second question. Now in the second question you have f is a function which is given in roster form. Okay, ordered pair 1, 2, 3, 5, 4, 1, and g is a function 2, 3, 5, 1, 1, 3. You are asked to find FOG and GOF. So let's see what is FOG. FOG of x, that is f of g of x, right? This thing is same as what I have done here. Now which is a function that is acting first? That is g, right? Now we also will start from g. So this is equal to, it is a set of ordered pairs that we are going to find. Here it is very much direct. So g of x means starting with g. Starting with g means the first element of g is 2, 3. So I can write 2 is mapped to 3 and under f 3 is mapped to 5. So the first element in FOG of x is 2, 5. Right? Starting with g. Starting with the elements of g. Because the extreme right is g. So starting with g, the first element is 2, 3. Now 3 is mapped to 5 by f. So f of gx, f of g of x is 2, 3, 3, 5. That is 2, 5 is the first ordered pair. Now coming to the next element, 5, 1. So 5 is mapped to 1 and the f when it happens 5 to 1, 1 to 2, 5 to 2. This is the easiest way of doing it. Just understanding what it is and then proceeding. Now coming to the third element, 1, 3. Then in f 3, 5. So 1, 5. Am I clear? Am I clear to this? FOG of x. The first function that starts up with is g. So g of x. G of x means what? In the function g, the ordered pair starts with 2, 3. 2 to 3. Then comes f. So 3 is mapped to 5. So 2, 5 is the first element in FOG. Then 5, 1. So 5, 1. 1 is mapped to 2 by f. See, f is here. So g, starting with g, applying f. So 5 to 1, 1 to 2. So ultimately what will I get? 5, 2. Then 1, 3. 3 to 5. So 1 to 5. That is the third element. I hope it is clear. Now, what is GOF of x? That is g of f of x. Isn't it or not? The extreme right, which is the element function there, f. So starting with f, it is again the set of ordered pair, f. Starting with f, 1, 2, 2 to 3. So 1, 3. Right? Again starting with f, 3, 5, 5 to 1. That is 3, 1. Then 4, 1, 1, 3. So that is 4, 3. Am I clear? Starting with f. Starting with f, 1, 2. Then here g acts upon 2, 2, 2 to 3. So 1, 3. Then starting with f, 3, 5. 5 to 1. So 3 to 1. That is the second element. Now 4, 1. 1 to 3. 4 to 3. That is the third element. So this is GOF and this is FOG. Hope you understood. Now let's see another example. Here the question is, let f be a function from R to R. Given f of x is equal to x square minus 3x plus 2. You are asked to find FOF. Okay, FOF. What is FOF meaning? It is same as f of x. Right? f f of x. That is f of, what is f of x there? X square minus 3x plus 2. X square minus 3x plus 2. Now f of this expression, what is it? Expressing this in the place of x. So I get it as x square minus 3x plus 2, the whole square minus 3 times x square minus 3x plus 2 plus 2. Okay, so this is f of this expression, is substituting this expression in the place of x. Here f of x. Here first what did I do? I substituted for f of x. The entire expression of f of x comes here. Now this expression is replacing x in f of x. So I get an expression in this form. Now this is, either you can leave the function in this form, or else what you can do is you can expand it and write the answer in the simplest form. That is x square minus 3x. I write this as the square plus 2 into 2, 4 times x square minus 3x plus 4 minus 3x square plus 9x minus 6 plus 2. Okay, I'm just expanding it. Using here I have expanded by taking this as the first term. So a square plus 2ab plus b square. Okay. Now on expansion, what will I get? X raised to 4 minus 6x cube, right? 6x cube plus 9x square plus 4x square minus 12x plus 4 minus 3x square plus 9x minus 6 plus 2. On simplifying, what will I get? X raised to the power of 4 minus 6x cube. Then 9 plus 4 is 13. 13 minus 3 gives me plus 10x square. Then 12x plus 9x. Any other x? No x. So minus 12x plus 9x, that gives me minus of 3x. Then 4 plus 2, 6 minus 6, that cancels. So this is the final answer that I am getting on simplification. So this is not an important part either. You can leave it here also. There is no much issues there. But if it is a 1 mark question, definitely we expect an answer like this. Okay. So this is how it happens. So f of is same as f of x. In the first place, this f of x is replaced with this expression of f of x. Further on, this entire expression is replaced in the place of x, and then I expand and simplify to get a simplified version. So this is how you find f of f. Okay. So that's it. Just go through it.